Good morning to college algebra students. We're going to get ready to do Unit F, Section 3. All right, just shared my screen. So let's warm up a little bit with what we were doing in the last lesson, simplifying radicals. The one thing you have to remember is that when you take an even root, you must do the plus or minus. If you take an odd root, your final answer could be positive or negative. If you take an odd root of a positive number, you're going to get a positive answer. If you take an odd root of a negative number, you will get a negative answer. So for example, we're taking an even root. Oops, let me grab a pen. An even root of a number, so our answer must be plus or minus. So the square root of 225 is 15, so your answer would be plus or minus 15. Here we're taking an odd root of a positive number, so we know our answer will be positive. And if you put the cube root of 512 in your calculator, you'll get 8. Here we're taking an odd root of a negative number, so we know our answer will be negative, and the cube root of 64 is 4. Here we're taking an even root, and the fourth root of 1296, if you put that in your calculator, of course, since it's even, we need the plus or minus. There are two possible answers, and the fourth root of 1296 is equal to 6. Okay, so today we're going to learn about adding and subtracting radicals as well as multiplying radicals. The one thing that you have to remember about radicals is that they're like terms, right? If they're like terms, they must have the same index. Remember, this is your index. So if there is no index, it's assumed to be the square root, but if there's a number there, then you have to abide by that. And then the number under the radical sign is the radicand. Let's make that more legible. So in order to be like terms, they have to have the same index and the same radicand. Then you can combine it. So of course, first you're going to simplify all radicals. So let's try this first step. Let's see. You can take 27 and rewrite it as 3 times the square root of 9 times the square root of 3. So 9 times 3 is 27. And square root of 12, we can write as the square root of 3 times the square root of 4. So we're still simplifying everything at this point. So there's 3, then the square root of 9 is 3. Bring down square root of 3 that we can't do anything with. Bring down this square root of 3. And the square root of 4, we can simplify to 2. So what we have here is 3 times 3 are 9 root 3s minus 2 times 2 is 4 root 3s. All right, so now we're in step 2. Once we've completely simplified everything, then we can identify the radicals with the same index and same radicand. So root 3 has the same index, it's implied to be a 2, and the radicand is also the same. So we have like terms. Let's make this legible. So we have 9 minus 4 root 3s, or 5 root 3s. So really 2 and 3 are combined. So once we've identified that we have like terms, then we can just add or subtract them. All right, number 2. This we can rewrite. Now we want perfect cubes, right? So 54 can be separated into the cube root of 27 times the cube root of 2. And it would be good for you guys to have a chart. I'll make sure and post that, of perfect cubes and perfect squares and perfect fourths and all of that. And that will help you to decide. All right, so now I'm going to bring down 2 cube root of 2. And what was that? And 7 times the cube root. 1 perfect cube is 8. And 8 times 2 is 16. Now we're going to simplify. Let's see. The cube root of 27 is 3. Just going to bring this down. Nothing we can do with that. And we can simplify here. Cube root of -8 is -2. And then we'll just bring this down, cube root of 2. All right, so 3 times 3 is 9. Cube root of 2 minus 2 cube root of 2. And we've got 7 times -2, that's -14 cube root of 2. So we've got like terms. So all 3 of these are the cube root of root 2. So we've got 9 minus 2, that's 7. And then 7 minus 14 is -7. So we've got -7 of these things that we're calling cube roots of 2. All right, let's keep going. Okay, so first we're going to simplify the 4th root of 48. And I know a perfect fourth is 16. So here's 7, 4th root of 16. And 16 times 3 is 48. Now, the 4th root of 3, there's nothing we can do with that. So we're just going to bring it down. And then the 3rd root of 72, let's see, 8 times 9 is 72. So we can say cube root of 8, since 8 is a perfect cube, times 3 times the cube root of 9. Now remember, when you're simplifying radicals, you can always use a factor tree to get it down to its basics. And maybe the next problem I'll demonstrate that for you. Okay, let's see what we have. 4th root of 16 is 2. Can't do anything with this or this. Whoops, that should have been 4th root. Let me erase that. But the cube root of 8 is 2. So this would be 3 times 2. And we can't do anything with, I want to make sure, let's see, yeah, that's right, okay. So this would be 3 times 2 times 3 cube root of 9. All right, so 7 times 2 is 14 of these things called the fourth root of 3, minus 2 more of these things called the fourth root of 3, plus 3 times 2 is 6, and 6 times 3 is 18 of these things called cube root of 9. Now we have to identify the like terms, or the only like terms are these two. So we've got 14 minus 2 of these things called fourth root of 3, plus this other thing which does not have the same radicand or index, so we can't combine them. I know what we did wrong. I did wrong, sorry. This 3 I put down twice. Yeah, it shouldn't have been there. So this should be 6. Yeah, so I was simplifying. Let me get my cursor here. Clear this up. So I'm simplifying 3 times the cube root of 72. So here's the 3, I already put it down. And the cube root of 72 is just 8 times 9. So once we evaluate the cube root of 8, that's just 2. So this should have been a 6. And that's the final answer there. Okay, moving along. So we're going to simplify the square root of 28. So think of factors of 28. Well, 4 times 7 is 28, and 4 is a perfect square, right? So 10 square root of 4 square root of 7 will take care of 10 root 28, plus 56 would be 7 times 8. We know that 8 is a perfect cube. And we'll put that negative with 8. So 8 times 7 is 56. Now we'll bring down the 4, square root of 175. Well, I know that 25 goes into 175, so you could say 4 times the square root of 25 times the square root of, let's see, how many quarters in $1.75? That would be 4, 5, 6, 7. And then just simplify. So this would be 10. Square root of 4 is just 2. Bring down the root 7. Cube root of negative 8 is negative 2. Bring down root 7. Bring down the negative 4. Square root of 25 is 5. And bring down the root 7. Now let's just simplify by multiplying the numbers on the outside. So 10 times 2 is 20 root 7. This would be plus a negative, same thing as minus 2 root 7. 4 times 5 is 20, so it's negative 20 root 7. Now, what are the like terms? All three of them are like terms. So 20 minus 2 is 18, and 18 minus 20 is negative 2. So your final answer is negative 2. Oops, this should all be cube root of 7. Oh, no, they're not. Notice, I'm actually glad I made that little error, because notice this is not the same index as this or this. So let me go back. Oh, it's funny, it's in the answer key like that too. So even the writer of this got that wrong. Okay, so let's try this again. All right, so we've got 10 and square root. That would be square root of 28. Oops, I want to use red to demonstrate I'm on the red step. So we've got 10 times the square root of 4 times the square root of 7 plus cube root of -8 cube root of 7 minus 4. Now we're talking square root of 25 times 7, since 7 times 25 is 175. Now we'll simplify. We've got 10 times 2 root 7 plus -2, cube root of -8 is -2 root 7 minus 4 times 5 root 7. All right, so now we'll simplify the numbers on the outside like we did before. We've got 20 root 7 minus 2 root 7. Oh, I guess we got rid of that cube root. Oh, no. This should be cubed. Okay. This is, I think, where I messed up before. This is the cube root of 7, right, from up here. Okay. And now we're going to subtract 20 root 7. So those are the like terms. So 20 root 7 minus 20 root 7 is just 0. That's why your final answer is -2 cube root of 7. That was a tricky one. All right, let's do some more. All right, I promised that I would do it using factor tree. So let's take 98. 2 times 49, 7 times 7. So what we have here is a pair of 7s that can come out. So 1 7 will come out, and the 2 has to stay in. So we've got x to the 4th y squared minus 3x squared y root 2. Okay, so that's using the factor tree method to simplify the number part. And remember that when the index is 2, that's the number you're going to divide by to get terms out. So we have this 7, and then we have x to the 4 divided by 2 power, 2 index. And then we have y squared divided by the index. Minus 3x squared y. Nothing we can do with that root 2. What's left, though, in there is a root 2 from right here. Okay, now let's just simplify. We have 7x squared y to the first power, root 2's, minus 3x squared y, root 2's. So that's the same thing as 7x squared y minus 3x squared y is just 4x squared y of those things called root 2. I can color code this a little better. Okay, let's see, next problem. Let's see, 40 would be 8 times 5, and we know that 8 is a perfect cube, right? So we're going to rewrite this as the cube root of negative 8. Oops, make sure that cube root shows up clearly. Times the cube root of 5 times, now we're going to take a to the 7th. Since 7 is not divisible by 3, we're going to break up a to the 7th. Like a to the 6th times a to the 1st. That would give you your a to the 7th. 2a squared, just bringing it down. Cube root of 135 is the same thing as 27 times 5. And then to take care of the a to the 4th, we can say a to the 3rd times a to the 1st. All right, squeeze that in there, right? Okay, so the cube root of negative 8 is just negative 2. So now we've got square root of a to the 6th. So that's the same thing as saying a to the 6th over the index, which is 2. Times the square root of a to the 1st. No, cube root. Let's see, where am I here? Okay, I'm still 6 over 2 and cube root of a. Let's make sure that looks like an a. All right. Now we're on to this term. So 2a squared times the cube root of 27 is 3. We've got the cube root of 5 and a to the 3 over 3. And then the cube root of a. Okay, now we're simplifying. All right, so we've got negative 2. A to the 6 over 3 is a cubed. Cube root of 5. And this cube root of a. So we've taken care of that whole first term, this whole thing there. Here's the plus sign. And we've got 2a squared times 3. Actually, let's do that math. 2 times 3 will give you 6a squared. And then there's another a coming out, so that would be a cubed. So we've got 2 times 3 and a squared times a to the 1st is a cubed. And then we're left with 1 cube root of a. So let's see if these are like terms. Cube root, oh no, I forgot the 5. 5a. Okay, so we do have like terms. So negative 2a cubed plus 6a cubed is 4a cubed. And then we still have the like term, which is the cube root of 5a. All right, so that's adding and subtracting, where you simplify first and then you collect like terms. Multiplying radicals uses this rule that if you multiply something with the same index, you can just, and the radicands don't have to be the same. So if you take the nth root of A and multiply it by the nth root of B, as long as the index is the same, you're allowed to multiply A times B. Okay. So what we do first is multiply any coefficients. Coefficients would be the numbers on the outside. Then use the product rule. So if we take the square root of 25 and multiply it by, the square root of 27 by the square root of 5, and you're just multiplying those two numbers. So you get 25 times 5, which equals the square root of 135. So you could use the factor tree method, right? So you could say 135 is 9 times 15. 9 is 3 times 3. So you've got a pair of 3's that you can take out. So you take one pair out, but what's left is the 15. And you're done. All right, so here we're going to multiply the coefficients. So we're going to take 3 times negative 2. And then we're going to use the product rule, which says that root 10 times root 18 is equal to root 180. Then you could use a factor tree on that if you like, or you could use two perfect square factors. So if we do a factor tree on 180, we know you're going to get 10 times 18. So here we're going to simplify this. So we've got negative 6 on the outside. Oops. We've got a pair of 3's and a pair of 2's. So we bring a 3 out and a 2 out. But we're left with this 5 all by itself. That has to stay under the radical sign. And then we just simplify from there. So we have negative, let's see, 18 times 2 is 36, negative 36 root 5 is your final answer. Now the same thing goes for something that's a cube root or fourth root, right? As long as the index is the same, it's legal to do. All right, so what first we're going to do is multiply the coefficients. So we've got 2 times 5, that's 10. And then we're going to use the product rule. So we can say that this is equal to 9 times negative 24. Which is negative 216. And 216 is a perfect cube. So we have 10 here, and the square root of the cube root of negative 216 is just negative 6. So we get negative 60 as our answer. All right, here we're going to start by multiplying the coefficients on the outside. So -3 times -1 is +3. We're going to use the product rule. So 64 times 8 is 512. And 512 can be separated as 256, which we know is a perfect fourth, times 2. So the fourth root of 256 is 4. So our final answer is just 12, fourth root of 2. All right. Let's just do a few more of these examples. I've given myself a little bit more room here. All right, so we're going to multiply the coefficients on the outside. The only coefficient on the outside is 5. Then we'll multiply the inside. So we've got 6 and 8, that's 48. And x to the 4th and x to the 5th. Well, that's x to the 9th. So I'm going to write this as x to the 8th because I want it to be divisible by this index, which is implied to be a 2. But I have a total of 9 x's, so I have to add another x to the first there. All right, so we've got 5 times the square root of 16 square root of 3, since 16 times 3 is 48, square root of x to the 8th square root of x. So let's just simplify. The square root of 16 is 4. Bring down the root 3. This would end up being x to the 8 divided by 2. And this would just be the square root of x. All right, so 5 times 4 is 20. This would be x to the 4th root x. Now we're just going to move the x to the 4th up front, 20x to the 4th. And we're left with 3 and x under the radical sign. Okay. All right, so there's no numbers on the outside. So we're going to use the product rule here. So we'll say we've got the cube root of 54 times 5 is 270. And we've got m to the 12th. And we're just going to keep that since 12 is divisible by 3. So we'll set this up. Well, I know that 27 is a cube root. So we'll split that up as cube root of 27 and cube root of 10, since 27 times 10 is 270. And then this is just going to be 12 divided by that index of 3. So let's see, the cube root of 27 is 3. And then we'd have m to the 4th, right? 12 divided by 3. Oops, I don't want to do that. And we would just have the cube root of 10 left over. And we're done. Let's see, number 13. No numbers on the outside, so we'll just go right to the product rule. So we've got the cube root of -108. And we've got a to the, how many a's do we have? 13. So let's make 12 and a to the first power, since we know 12 is divided by 3, 13 is not. And how many b's do we have? B to the 4 and 2 would make 6, and that is divisible by 3, so we'll just leave it like that. All right, so we'll split up 108 as the cube root of negative 27 times the cube root of 4. Then we've got let's see, a, that would be 7 and 6, 13. So this is a to the 12. So this would be a to the 12 divided by the index of 3. And then we would have a to the first left there. And then we would have b to the 6 divided by the index of 3. All right, so cube root of negative 27 is negative 3. Just bring that down. Got a to the 4th and b to the 2nd. So anything that doesn't have a radical comes outside. So we've got negative 3 a to the 4th, b squared, cube root of 4, and we also have an a left under the radical sign. All right, and one more. Numbers on the outside, multiply those first. You got 14. And then the 4th root of, let's see, how many p's? We have 5 p's, and we want it to be divisible by 4. So I'm going to break those 5 p's into p to the 4th and p to the 1st. Now q's, we have 11 q's. So I want it to be divisible by 4. So I'm going to split it up with 8. And 3 makes 11, but 8 is the biggest number divisible by 4, right? That's why I chose that. Okay, so we've got 14 on the outside, and this is the 4th root. P to the 4 over the index, and Q, 8 over the index, and we're left with P under the radical and Q to the 3rd power. So we've got 14 P to the 1st, Q squared, 4th root of PQ to the 3rd. All right, guys, that's all I have for you today. There will be an assignment on Schoology for you to do, and I hope you have a lovely weekend.